Hey everyone, very good morning. Thank you so much for joining us today. My name is Mohit. I'm a developer advocate here, and welcome to this session on best practices for building Agentforce actions. How many of you are familiar with Agentforce? Okay, a lot of you. And how many of you build Apex actions specifically? Okay, a few of you, great. As I said, my name is Mohit, and I have the pleasure of having Daniel. Daniel?
Hello, yes, I'm Daniel Ballinger, the product manager for Apex.
All right, before we begin, you'd have seen this slide a number of times today, but I'm going to just skip. And I want to take a moment to say thank you. Again, there's a lot of things happening, so thank you for making time for this session. So here's our agenda today. So what are we going to learn in this session? So today we're going to learn about building, designing your Apex actions. So everything around it. So we're going to understand, how the developer workflow is changing with Agentforce, understand the reasoning engine, and then how do we properly design these actions, considering all of considerations here, and how do we take care of security and best practices here. Okay, so before I get started, I wanted to share this slide because it's very important to understand that the actions that you're building, especially the Apex actions, they are going to be part of this broader Agentforce setup that either your business analyst will do, or maybe admins, or maybe you are building. So it's not just about unit testing and building your Apex actions, but it's more about broadly understanding how this Apex action fits into this business process that you're trying to solve. And one of the things is there is definitely a shift in how you build and design this. So what does the development or the developer workflow look like from Agentforce perspective, right? So that's what we're going to discuss in this slide. So really the way you start is you think about your business process, and then you come up with, okay, what are the jobs you want your agents to accomplish? And that becomes your topic. So you really start by defining a topic, like what is that business goal that you want to accomplish? And what is it that your agent is doing? So that becomes your topic. So you will have multiple topics, and then per topic you will create actions. So actions are the capabilities that you want your agents to take for that specific jobs to be done. So you add your actions to the topics, and then very important thing, and this is what is changing, is you will be writing topic instructions and action instructions. So instructions are nothing but natural language descriptions that you write on how you want your actions to behave and how the user interface is going to be. What are the things, what are the questions that this agent is going to ask? How is it going to process that information and push to these actions? So that is very important to understand. And there are different types of instructions that you'll write. You'll start with classification descriptions, because you want to understand first from the prompt or the query from the user, what is this topic that this particular query belongs to. So that is your classification description. So you need that topic classification description. You need to get that thing right. And then you will have instructions around actions, like what should your actions do? What are its parameters? What does these parameters mean? Output parameters, what do they mean? And then actions, what does this action do? How does it behave when it compares to other actions? So there's a lot of things to consider. So your actions is just part of this whole big topics and instruction set. So that is very important to understand, because it's no more about just building your Apex and unit testing it. It's about how your Apex is going to work for this specific job. And with that, let's a little bit deep dive into understanding the reasoning engine. Like, what is this reasoning engine? So LLMs are not enough, because they can come up with plan. The good thing about LLM is if you give LLM that, hey, this is my problem, and these are the 5 different actions to solve this problem, the LLM can come up with a plan. But LLMs are not enough, because what you really need here is a reasoning engine that can not only just plan, but you have to evaluate that plan. You have to refine it based on the human feedback. And then you have to be able to take actions, connect with the software. Like, there needs to be a bridge between LLM and these tools that we have, like Apex and Flows. So that's why we have this reasoning engine, because that's what it's doing. It's planning, it's evaluating, it's refining, it has integrations with these actions. And then finally, it has to reinforce the learning. There will be human feedback from the outcome of this. which is all going to be stored in data cloud. So all that data needs to be again reconsidered, and that there is a loop, as you can see. There's an outcome, and you retrieve that context. So further to understand this, we have the slide. So how does the Atlas reasoning engine works, Daniel?
So under your topic, you're going to have a range of actions. Here we've got a whole heap of actions, and your agent's going to get some sort of prompt. And then it's going to be on to the reasoning engine to say, of all these actions, which ones are actually applicable and interesting to what I want to do. So it's going to have to sort of say, I've got this task, I'm trying to find the status of an order, it's got an order number. So to be able to process that, it's going to need to say, I need this action. First, I need to go find the order with the correct status. I need to check its status. I then need to return that information back to the user. Perhaps I need to format in a particular way via another action. And then let's look at how that actually works if we look at that actual prompt. So again, the prompt is, what is the status of my order? And I have a particular order number. And then to actually process that, there's a couple of things it's going to need to do. First, it's going to need to figure out what your intent is, and then find an appropriate action that corresponds to that intent. I want to know the status of my order. And it's also going to need some additional data to process that action, such as, what is my actual order number? So the reasoning engine is going to need to extract all that. And I think, Mo, we have an example or a demo that runs through that.
Yes, we'll run through the demo now, but one key thing to understand here is the Atlas reasoning engine is doing the action orchestration for you. Typically, you as a developer orchestrate these things, and that's more controlled, right? But here, the workflow is the Atlas reasoning engine. You provide capabilities to the system, and the Atlas reasoning engine is orchestrating these actions for you. So there is a difference between that. So sometimes you need control, sometimes you need to give autonomy. It's all about balancing that based on your business need. So let's actually move on to the demo and see this in action. So really, to make it simple, right, I have 2 orders here, and we are working, we have an agent which is going to really help internal users of Salesforce to manage these orders. So for example, here's the topic that we have, and as I said, you will have topics, because topics are the jobs to be done by the agent. So in this case, the agent is doing order management. So you need classification description first, because when the user says, hey, do something related to the order, the agent need to be able to understand that this is an order management topic, right? So you need the order, and then you need to restrict, you need to put a boundary on what are the things that the agent can do. And that's why you need scope, because the scope is going to put a boundary around, this is all the things you can do within this topic. So that's why you need scope. And then you need instructions. Again, instructions are for guiding a little bit to the users. It's like an UI. You can think of it like both UI, and then a little bit of, it provides a guidance of how to orchestrate these actions. First of all, you'll have action descriptions, like I can show you here, right? So these are actions. So here we have very simple actions. I can check the order status. I can get all the orders, let's say for this month or for this week, and then I can update the order. So these are all the capabilities in the order management that this agent has access to. And just to give you how to create these actions, it's pretty simple. All you do is you say create new actions, and then you have different actions here, but we're going to focus on Apex. And Apex has 2 categories now. You can either bring Apex REST methods or invocable methods. So one thing that is very important to understand is only invocable methods can be brought in as agent actions. So if you look at my code here for the check order status, you see that we have this order status variables. And then one thing that is very important to understand is this is the request or the input variables, but we are now writing natural language descriptions. We are giving labels, we're giving descriptions, because we need the reasoning engine to understand what this variable is all about. Same thing with responses. We need to provide descriptions now. And the same thing applies to the method. You will have invocable method, but you will need to make sure that you provide descriptions, because that is how the reasoning engine understands what this particular thing should do when the user submits their prompt, right? So here we say, okay, you want to check status, right? Very simple. It's basically looking at the order number, and then it's querying, and then it's returning the status and the last modified date of the order, right? So basically, if you have an invocable method, you will see here, like let's say in this case, check order status, right? We go next, and you can configure again. If those variables, if you put descriptions there here, those will automatically come here, so you have to do less work. But somebody can override too. Sometimes if you want to override, and then select what you want to show in the output. So in the interest of the time, right, I've already added these actions. So let's actually check out a simple example of this working, and then we'll check out one complex example too about action chaining. So I'm going to say, show me the status of this order. So this is Agent Builder, by the way. This is where you build and test, and also test the reasoning, whether your right topics are getting triggered, whether, so as you can see, it was able to give me the order status. So you can see it selected the right topic, and then it was able to find out that check order status is the action that it needs to accomplish. So it was able to go execute that action, and then finally it gets the responses back. How about we take another example, which is a little more complex, like for example, which involves, chaining. These actions can be changed. If the query gets complex, as I said, it looks at the query and says, okay, these are the actions that I need. So let's put another, complex query. For example, I want to say, find the orders, or we'll say fetch the orders for this month, and then update its status to activated. Now, how many of you think that, how many actions it's going to execute? How many of you think 2? How many of you think 3? So I have, just to give you, right, this query is going to return 2 orders. There are 2 orders for this month, actually. So how many of you think it's going to be 2 actions that it's going to invoke? And how many of you think it's 3? 2? How many of you? 2? Okay, 3? Okay, let's see what happens here. We have divided audience here. So let's see. So I said fetch the orders for this month, and then update its status to activated.
Did we give anybody the option of 4?
No, it looks like it decided to do nothing about it. Let's try. Sometimes the agent agent requires probably morning coffee. Oh, it's fun. Agent decides not to do anything. Okay, that's interesting. Let's try one more time here. Let's try with different prompt here, Get the orders.
Should we give away the ending while you're putting it together?
Yeah.
I mean, so it's going to essentially have to fetch the orders, and now the only action it actually has to update those orders can only work on one order at a time. So it's going to need to do one action per order. And that's going to start adding up, especially if you have a large volume of records that need to be updated. We'll go into that in a bit more detail, but we'll see if we can get that demo to go.
All right, let's see. Let's see if this works this time. If not, we'll just move on. Oh, okay. So it did say, please fill you want to fetch. Okay, draft orders. Okay, that was good.
Should we move on in the interest of time?
Yeah. We'll just
one more time.
One more time. I just said draft orders. Maybe it's thinking now. Okay, it did.
Nice.
It did the stuff. So as you can see, let's look at the planner now. So as Daniel was talking about, it did fetch orders, and then it went and updated each of these orders. So if I go look at these orders, now both of these orders changed to activated. But you see, there were 3 different actions now, and the update order ran 2 times. And that is a very fundamental thing to understand if you're a developer. So what are some of the best practices here, Daniel, when it comes to designing Apex actions?
So yeah, you need to consider that your actions are, oh, hang on, is this your slide?
Yeah. So let's talk about designing Apex actions, right? So first of all, some of the best practices are, as I showed you, right? You need to make sure that your invocable method has a name that it reflects what it does. Clear natural language descriptions for methods, inputs, and outputs, as I showed you. Make sure that natural language descriptions are part of your code, because they can break and make the functionality. If you don't get it right, the agent is going to behave really weird, right? And beware of this. This is something very important to understand, is reasoning engines context window limits. So these large language models have context window. That means they can only hold certain amount of information, okay? Like some of these large language models like Gemini have got 1 million context window. but some of these models have lesser context windows. So what does it mean? It simply means that if you have really complex set of instructions, and if you really do not reduce the complexity, and if you, let's say, add 20 actions per topic, you will find that the agent is not, agent will find hard to accomplish these actions or understand you. So it's very important to break them into topics. Also, if your instructions are getting longer, see if you can move them into a prompt template and convert into an action. That way, the agent finds action, then reads everything within the prompt template. So that is a very important concept to understand. And again, cannot stress enough, make sure you track all the code changes, including natural language descriptions. So let's talk a little bit about the chaining behavior that I showed you.
Yeah, so as we saw in that example, the actions weren't bulkified. So if you're updating multiple records, you're going to need to do multiple actions, and that's going to have implications. So you're going to have multiple transactions. Each of those transactions gets its own sets of limits. Each of those transactions has its own boundary, so if something goes wrong, it's going to roll back just that transaction. So you need to consider what state it's going to be. And then also, if you have multiple actions that are actually dependent on running in a particular order, you need to indicate to the agent via the action instructions that that's something that needs to consider to keep them in the expected sequence.
And what are some of the error handling best practices here?
So, standard Apex error handling applies. You should have try catches, but when you do catch the exception and you're going to bubble it up out of that action, you need to consider how the LLM is going to react to it, how the agent's going to see it. Do you need to give it a user-friendly message? Do you need to give it an agent-friendly message? And then when that rollback does happen, yeah, as I said, that individual transaction will roll back, but adjacent ones won't necessarily do so, or they won't do so. So that's certainly something you need to consider when you're implementing your actions. It might be if you have, that's, as we said, they won't roll back the adjacent transactions. I think that was that main point on that one. And then the next one is, if you have a sequence of actions that do need to happen together,
yes,
you need to basically build them up into one individual action so you can assure that when that transaction rolls back, you leave the database in a nice consistent state.
Yes, and I think this is very important to reiterate, right? There is, actions executes in its own thread, and sometimes you don't want that behavior. You really want it to be like, how you want. Like, you want to be able to control that rollback mechanism. In that case, you have to build a composite action, okay? So that's why you need to build a composite action if you want to control that rollback behavior of the records. And then I cannot stress more importance on testing this. So agent builder, use it to test your planning and the reasoning, but sometimes it's like you want to test it in bulk. Now we have testing center. So testing center is really awesome because what you can do is you can come up with different variations of the utterances. It can auto-generate for you. Also, you can manually write. And now you see, I'm able to at least assert that the right topics are getting picked. This is my topic. This is my expected actions. I can also compare actions and see if agent is able to invoke the right actions. And finally, I can also compare what is the expected response versus the actual response. So making sure that you really use this testing center for bulk testing and refine and you might have to iterate on your topic instructions, make sure that it's working. So more accurate you get with that, more better predictive results you'll have. And for Apex actions, make sure you write Apex unit tests. That's just mandatory still, 75% coverage, but just don't write for 75% coverage. Just make sure your Apex test is also like there. So there are two parts now, right? You'll test your Apex unit test, but then you also need to test now the reasoning engines, capability to reason and plan. All right, so the next thing that we want to talk about is security best practices. And one of the things I want to mention is, remember that these employee agents runs in user context. However, the debug logs today show as platform integration users. So you need to turn that log to be able to trace down your Apex. Agentforce service agents runs as assigned Salesforce users. That is very important to understand. Even if you have like 10 different users, they still run as that one single users. And that's why you need to authenticate that user action. And also, if your action is public and if you're exposing something on a public website, just be mindful. Limit only to fields that you think are necessary. And make sure your Apex class has with sharing.
Yeah, standard security practice applies. You want your operations to use with sharing, and any DML or SOQL queries should use user mode to lock down just what that user has access to.
Yeah, and then there are some performance practices. Like, for example, if you're hitting CPU timeout, investigate if you can break into multiple actions, because every action gets 10 seconds of CPU. Synchronous CPU time. and offload intensive tasks to Heroku. So you can offload that. Sometimes you want to do some things like image processing, etc. Those things Apex can't handle, so you have to offload. And then write optimized SOCL and ensure queries have sufficient filtering. And if you're facing LDV, remember, you have now Data Cloud. So you can use Data Cloud, and you can use features like calculated insights or enrichment to bring that data. And you can use Apex also to query that data there. It's going to be much faster and much performant compared to using SOCL. And then finally, use asynchronous processing for long process. But ensure you return the response as soon as possible. But then, once the job gets completed, you can notify via email or final result. And finally, bulkify your actions. If you think you can use the actions, if you think your users are going to use it with multiple rows, make sure you bulkify them. With that, thank you so much for joining, and we'll be off stage for any queries.
Thank you, everyone.
Thank you.